Hello everyone. Let's start chapter 13 about blood. Let's first talk about the function of the blood. As we know, blood is a transportation system to carry respiration gas like oxygen or CO2, and then also is going to carry some nutrient and at the same time can carry the waste material that needs to be dumped. Besides that, your circulatory system is used for regulation of the temperature. As you know, when your body is hot, the blood is going to come to the surface of the skin, so you're going to lose heat. And also, blood is used for protection. Inside your blood, you have some white blood cells for fighting, and then also you can create clots that protect you against losing blood. Your blood is a connective tissue, but is a fluid type of tissue. The temperature of blood is slightly higher than your body temperature. Your body temperature is 37 degrees of Celsius, but blood temperature is 38 degrees of Celsius. The amount of blood that you have is between 5 to 6 liter. In male is a higher because of the size of the body and also because of the release of testosterone. In female is a less, between 4 to 5 liter, again because of the body size and also because of menses. If you put your blood inside a tube and let it stay, your blood is going to clot. Here is the clot at the bottom of this tube. What is remaining is a fluid on the top. This fluid on the top is called serum. If I put the blood inside a test tube and I add some anticoagulant to this blood, that means I don't want this blood to clot. And then if I centrifuge this tube, if I spin it very fast, everything inside the blood, all the elements is gonna settle down and fluid is gonna stay on the top. This fluid on top is called plasma. So what's the difference between plasma versus serum? A serum is a fluid that at the bottom of the tube we had clot. Plasma, at the bottom of the tube we didn't have clot. We have every element inside the blood, including red blood cells, white blood cells, and platelet. So, what's the difference between this fluid, serum, and this fluid, plasma? The answer is to create clot, we have to use some protein. If you see clot, that means you already used those clotting proteins. In other words, this fluid, this serum, does not have clotting protein anymore. However, in this case, since we don't have clot yet, this fluid still contains clotting protein. Therefore, I would say serum is just like plasma, but minus a clotting protein. The most famous clotting protein that you need to know is fibrinogen. We're going to talk about this one later. As you can see in this picture, if you put the blood inside the test tube and prevent this blood to clot, then the fluid is going to be on the top, we call it plasma. The red blood cells, white blood cells, and platelet is going to stay in the middle. Red blood cells create 42 to 45% of the total amount of your blood. Plasma creates somewhere between 55 to 58% of your blood, and less than 1% would be white blood cells and platelets. Percentage of RBC is called hematocrit. The percentage of the white blood cells and platelet is called Buffy code. In this picture, you can see different elements inside the blood. The red blood cells, white blood cells, and platelets are considered formed elements. Why is called formed elements? Because not all of them are cells. For instance, platelets are not cells. Red blood cells, although we call them cells, but in reality they are not cell because they don't have nucleus, they don't have ribosome, they don't have mitochondria, so therefore they are not real cell. We call this element inside the blood formed elements. Now let's focus on plasma, the fluid part of the blood. Plasma mainly is composed of water, of course, but also it has ions, organic molecules, and some trace element, vitamins, and of course gases like CO2 and oxygen. Among all of these, organic molecule is the point of discussion for us. We know organic molecule contains carbon, so amino acid, protein, glucose, lipid, and nitrogenous waste like urea, they're all considered organic molecule. Among these, probably we have to focus on protein. There are many different type of proteins inside the blood. Here you can see only 3 of them: albumin, globulins, and fibrinogen. You already know about fibrinogen. We mentioned a few minutes ago. It's a protein for clotting purposes. Albumin is the most common protein in the blood. The second most common protein is globulin. The third common protein in the blood is fibrinogen. Protein makes up 7 to 8% of the total amount of plasma. Albumin has a few functions that you must know. The first function of the albumin is creating osmotic pressure. I hope you remember osmotic pressure from what we discussed in the beginning of this course. If you forgot, please go back and take a look at that. Albumin is a protein that carries molecule inside the blood. Albumin is non-specific carrier protein. You will see some proteins only carry one specific molecule. Albumin is different. Albumin is non-specific, can carry many different type of molecules. The second most common protein is globulin. Globulin is a very diverse group of protein inside the blood. We have different type of protein that goes under this group. When I say car, includes Toyota, Honda, BMW, Mercedes. Globulin is just like that. For instance, we have alpha globulin or we have beta globulin. These two can carry lipid and also lipid-soluble vitamins in the blood. We have gamma globulin. Antibodies that we have in our blood are gamma globulins. Some clotting factors, except fibrinogen, are globulins. Some enzymes are globulins. Globulins can be a carrier protein. Which one is more important carrier protein? Albumin, because by far this is the most common protein in the blood. But some globulins, they can also carry molecules. And the third protein that we mentioned a few minutes ago is fibrinogen. Fibrinogen also is a clotting protein, but is not globulin. This table shows albumin, globulin, and fibrinogen. As you can see, it says they are coming from liver. In this table, you can see another protein that is called transferrin. Transferrin is a protein that carries only iron. After discussing about plasma, let's take a look at our formed elements. The most common formed element is red blood cells. We have between 4 to 6 million red blood cells per microliter. The second most common formed element is platelets. We have between 200 to 500,000 platelets per microliter. And then we have white blood cells. We have between 5,000 to 10,000 white blood cells per microliter. We have two different types of white blood cells. One is called granulocyte, is the one that has granule inside. And the other one is called agranulocyte, the one that doesn't have granule. We have 5 different types of white blood cells altogether. 3 of them, they are granulocyte, they have granule, and 2 of them, they are agranulocyte. Neutrophil, eosinophil, basophil, lymphocyte, and monocyte. By far the most common white blood cell is neutrophil, 50 to 70%. The second most common is lymphocyte, 20 to 40%. Then we have monocyte between 2 to 8%. Then we have eosinophil between 1 to 4%. And basophil is the least number of the white blood cells, less than 1%. Let's now talk about hematopoiesis. How does your body produces blood? Hemo or hema means blood. Poiesis means formation. So how are we going to create blood? The answer is your red bone marrow, which is called myeloid tissue, and lymphoid tissue, they're responsible for making blood. Before you're born, all the blood formation happens in myeloid tissue. After you're born, your lymphoid tissue also is going to participate in white blood cell formation, and specifically is going to produce lymphocytes. But the question is, how does your bone marrow knows that you need to create blood? Well, the answer is bone marrow doesn't know. You have to release some chemicals, it's called cytokines, and these chemicals, they're going to go to bone marrow and tell the bone marrow to produce red blood cells or white blood cells or platelet. But who is going to release the cytokines? In a few minutes, I'm going to talk about the cytokines and who is going to release the cytokines. But for now, I want you to know when the bone marrow produces red blood cells, we call it erythropoiesis. Erythropoiesis is a formation of the erythro, red blood cells. Your bone marrow is very effective. Your bone marrow can produce 2.5 million RBC per second. The whole process of making red blood cells is going to take around 3 days. to make white blood cells, we have the process called leukopoiesis, formation of the white leuko. And finally, the process of making platelet is called thrombopoiesis, formation of the thrombocyte or platelet. The most well-known cytokines is erythropoietin. Erythropoietin is a glycoprotein that comes from kidney and tell the bone marrow to produce red blood cells. With the same token, we have some cytokines for leukopoiesis. Those cytokines are very different. I put here a couple of them, but it's beyond these two. The first one is called colony stimulating factor, or CSF. There are so many different colony stimulating factors, but generally speaking, this one is going to go to bone marrow and tell the bone marrow to produce white blood cells. The second type of cytokines that you need to know is called interleukins. We have many different types of interleukins as well, but the one that you need to know probably is interleukin 1, 3, and 7. The source of these cytokines are very diverse. When it comes to making platelet formation, there is a cytokine, it's called thrombopoietin. Thrombopoietin is produced by liver cell, tell the bone marrow to produce platelet. Probably some of you saw something like this in your anatomy course. I have no intention to go through detail of this one, but here's a few things that you need to know. There is a cell inside the bone marrow that is the grandfather for every cells in the blood, and that cell is called HSC, hematopoietic stem cell. Also is called hemocytoblast. This hematopoietic stem cells first is going to divide in two different cells. One is called myeloid stem cell, another one is called lymphoid stem cell. This myeloid stem cell is called common myeloid progenitor, and this lymphoid stem cell is called common lymphoid progenitor cell. Common myeloid progenitor cells is going to create everything except lymphocyte. In other words, at the end, this common myeloid progenitor cell is going to create erythrocyte, platelet, eosinophil, basophil, neutrophil, monocyte, except lymphocyte. Common lymphoid progenitor cell is going to produce only lymphocyte, B cells, T cells, and natural killer cell. So the CLP is pretty easy because produce only one type of cells, and that is lymphocyte. CMP is going to divide into three different cells. One is called CFUE, or colony forming units, E for erythrocyte. Obviously, this cell is going to change to RBC. Then it's going to create a colony forming unit, MK, or megakaryocyte. At the end, of course, it's going to create platelet. And also is going to create a cell is called GMP, and that is called granulocyte monocyte progenitor. This cell at the end is going to create granulocytes, which is eosinophil, basophil, and neutrophil, and also is going to create monocyte. To produce erythrocyte, CFU is going to be affected by erythropoietin. To create platelets, CFU MK will be influenced by thrombopoietin. And obviously to produce white blood cells except lymphocyte, GMP or granulocyte monocyte progenitor is affected by CSF, and that is colony stimulating factor. But as we said, we have different type of colony stimulating factor. Here's called GM, granulocyte monocyte. I think that's enough about this table. Of course, then you have many different cells in this category, and you're going to learn those later. Red blood cells, or erythrocyte, we said, although we call it a cell, but it's not a real cell, is a biconcave disc. Something like this, like a donut shape, is a biconcave. As we all know, erythrocyte doesn't have nucleus and doesn't have mitochondria either. So as a result, erythrocyte cannot use oxygen to burn things because mitochondria is missing. Inside the red blood cells, we have a protein is called hemoglobin. Hemoglobin is the one that carries oxygen. One molecule of hemoglobin carries 4 oxygen, and we have 280 millions of this molecule inside one RBC. The RBC doesn't have nucleus, and the result cannot produce protein. Therefore, it doesn't do mitosis. After 120 days, RBC will die. And finally, since red blood cells doesn't have mitochondria, so therefore cannot burn glucose with oxygen. Therefore, the ATP that RBC generates is through anaerobic metabolism. The RBC is very flexible, and the flexibility of RBC comes in part because of important protein that you find in the wall of the RBC, and that's called spectrin. As we mentioned, inside the RBC we have hemoglobin. 97% of the RBC is filled by hemoglobin. Hemoglobin mainly is in the peripheral part of the cell. Because hemoglobin is sitting in the peripheral, this center is pale. If the paleness of the RBC expands beyond 1/3 of the diameter of the RBC, that means you have less hemoglobin. And that is one of the tools that we use in the lab to find out if the patient has anemia or not.